Right, so we basically know three different rules, right? We know the power rule that we just learned, we know the quotient rule that we just learned, and then we have the product rule that we just learned. And then remember, we can also take the derivative of the sum of things. So like a plus b is just the derivative of a plus the derivative of b, right? So what we're going to do now is we're going to combine all those rules. And this can be kind of challenging at first, but it's made easier. So let me give an example here. Let's say I'm trying to find the derivative of something like this, right? So when I was first learning calculus, I would look at this and be like, I don't know where to start. But if you take a step back and you just look at it and you think about what two functions are held together, I would say that this function right here, f of x, is made up of two separate main functions, right, that are held together with this little plus sign. So I would call this one function, and I would call this the other function. So when I'm looking at this, I would say, okay, I'm probably going to have to do the product rule here, and I'm probably going to have to do the quotient rule here, and then just add those two together. Remember, you can always take the derivative of the sum of two things by taking the derivative of the first plus the derivative of the second. Right? So as soon as you start to realize that these big functions are just a synthesis of two smaller functions, that it'll make your life a lot easier, right? So let's do this problem real quick. If you're taking notes here, the first thing I would do is I would write, remember, d over dx. That means we're going to take the derivative of this in terms of x, right? And then what I'm going to do is I'm going to break that up. I'm going to take the derivative of the first part plus the derivative of the second part, right? And when I take the derivative of the first part, I should move this over here. Hopefully that goes away. That was an issue last time too. When I take the derivative of the first part, I'm left with, so derivative, leave the first alone times the derivative of the second, plus leave the second alone times the derivative of the first. Derivative of x is just 1. And then remember, our quotient rule is low d high minus high d low over low squared, and you're good to go. Or low d high minus high d low over low low. So at low d high, so I got the low and then the d high, that's where the 2x comes from, minus high, x squared times d low. Remember, the derivative of 2, since it's a constant, is just going to be 0, all over low squared, and you're good to go. Now, you could potentially leave it like this. We're going to clean it up a little bit. If you left it like this, we'd be forced to give you credit, right? Because this is all good. Sometimes, though, we're going to want to take this a step farther, and you'll know what we're talking about in a little bit, right? So you might want to clean it up a little bit more, but if you did leave it like that, you'd be okay. So if I clean it up a little bit more, I'm going to distribute that 2x into the cosine into the 2, and I'm going to multiply negative x squared times negative sine x. So that's how I get this right here. And then from there, you can just leave it. That one should be good to go. That's as clean as we're going to make it, right? If you wanted to FOIL the bottom out, you could, but we're not going to get anything to cancel out anymore. So let's just leave it like that. I got another one here for you, just in case you wanted another example. So again, when I'm looking at this, I'm seeing, okay, I have the product rule up top, and I have the quotient rule all together, right? So I'm probably going to do, the quotient rule is going to be the bigger piece, and then inside of that piece, like think of a Russian nesting doll, right? Where it's like builds bigger and bigger and bigger. Inside of the bigger quotient piece is going to be the smaller product piece, right? So let's, again, use our correct notation. We're going to do low d high minus high d low over low low. So low times d high, notice we just wrote it like that. You could take the derivative right away if you wanted to. Minus low d high minus high d low over low squared. And then from there we can just go through and simplify that. The derivative of y times 7y, that would be, we're going to leave the first alone times derivative of the second, plus leave the second alone times derivative of the first. And then same thing here, the derivative of this is just going to be a straight power rule, 2y. And that's it. So again, you could, if you wanted to, you could FOIL this out, you could distribute this in, right? But you're going to make your life a lot harder if you do that. Once you get into a good spot, you should be like, okay, this is a good derivative, I can move on. Typically, the farther you go, the more of a chance you have to make a mistake. So once you find the derivative and you don't have any more dys or dx's in that derivative, you should cut your losses and just put it neutral for a little while. All right, so you guys are going to have another activity on a Google slide deck. Everyone should get their own, and remember you guys are going to turn that in so we can see them. All right, have a good couple days here. We'll see you on Thursday and Friday.